Hello everybody, McGregor here, and today I have a little special video for you. Yesterday I decided to do a little bit of programming, and I made a tiny game in Unity. It's nothing special, but I did want to show it to you guys. And so what we're going to do is I'm going to show you the game, and then I'm going to show you a bit of the code. This is not really going to be a tutorial, but if you guys would like me to do a tutorial, let me know in the comments and I'll see what I can do. I'm not a great programmer, but I do know some stuff. It's just that I haven't programmed in about 2 years, at least seriously, so this was pretty good practice. But anyways, let me show you what we did. So this is a puzzle game. We have a photo. And what we do with that photo is we chop it up and we mix up the pieces, and then the player has to put the photo back together. So let me show you what I have. So just so you know, actually here, let me put that there. So here we go, and that is my cat Leo. He likes to sit like this. You win! So yeah, so that's all what the game is. Very simple, and if we want, we can actually increase the amount of pieces. Oop. Okay, his butt goes there. Let's see here. Oop. I think that's over there. Oh, we're getting somewhere. Okay, that goes up. Oops. Oh no. Okay, good. I think that, yes. Yes. Okay, I think that goes there, and I think this, no. Right there. That one there. This is intense. Okay, yeah. Over here? No. Over here? Yes. Okay. Okay, that's good. Yeah! Okay, and yeah, you could go really crazy with this. Let's go 20. Yeah. I'm not going to do that puzzle piece. Okay, so let me break down the game for you. So we got our camera here, and it's in orthographic view right now. If I was to put that down to 2, if I was to change this into perspective, actually, before I show you that, let me show you a bit of what the game looks like. No. I want it here. Here. There. Let me show you what the game looks like when you have it running. Because right now you don't see anything. As soon as the game runs, that's when everything pops up. So, okay, so there's the game board. So it's technically in 3D. But here it actually looks 2D. That's because of the orthographic view. If I changed it to perspective, you won't notice much until I start clicking on stuff. So if I click on that, you see it's kind of pops out. But let me change that back to orthographic. So when I select a piece, now it looks like here it's actually glowing, but it's actually not. What we are doing is I am moving the image up by a bit, and right underneath it I have another graphic. It's just a picture of like a little light, you could say that, and it makes this kind of pop out. And because we're in orthographic view, it doesn't show depth. so it doesn't look out of place, that sort of stuff. So, and then you select, and then it goes away. So I'll show you how we did that, and you can see the puzzle sections here. There's the camera. The game board is basically like my game manager, and then my you win screen. I could have done that better. And then down here we have all my assets. So the materials, the mesh. I'm using a quad right now. It's just, think of it as just a panel, and a panel has four sides. I made the quad in Blender, and the reason why I did that, let me just stop that, is if you look at a plane, I did it for optimization because I could use a plane. But if you look here now, mine only had four sides, like four vectors. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Assuming 11 that way. So that's already a ton of vectors just for something that's, not going to be bending or shifting or anything like that. So so here I got the cat texture. There he is. He's a fat cat. Then we got my scripts, which is done in C#. My scenes, that's basically a level is a scene. The main game menu is a scene. So yeah, prefabs are they're instances of an object. So if I want to, how can I put it, load multiple objects, I could just instantiate it, kind of create it on the fly, and they're all kind of the same thing. I could have them change and whatnot, and I think it's also used a bit for optimization. I'm not too sure, but anyways. And then, like I said, the mesh, and in here should be, I'm not sure what that one is. Particle, I don't know why that's there. And my material, which is what's applied to the prefab. To here, you can see here, this material, that is this right here. So yeah. Let's see here. So let me talk to you a bit about the scripting now. See here, that's the game board script, and that is this here. So this is the game board script. So I'm gonna try to walk you through this part. It's a bit like I said, I only programmed it yesterday. It could be done a whole lot better. But anyways. Let's see here. So this is the size. This is the number of rows and columns that the puzzle's going to have. This is the puzzle piece. That is, if we go here, so the puzzle section. That is that here, the prefab. Sorry, I just keep watching my time because I did actually record this once before and it crashed. So I have to do this again, but you guys are worth it. Let's see here. Number of random passes. That's how randomized we want our picture to be. If this number is too small, there'd only be a couple of puzzle pieces out of place. So, then we got the two-dimensional array of the puzzle. And we got the scale, that's the size of the pieces. Then we got this here holds your selection. So when you select a puzzle piece, that's what this is, and this is the graphic. That's that light basically in the background behind the selected puzzle. So here I just get the puzzle ready. Here the way I build the board is I actually have the board created first as if everything is placed in its correct spot. And that's what this is doing here. So here I'm just getting the component puzzle section. That's this. I'm saying, hey, you are this script. So I'm casting it. Basically, with casting is because this here is a game object, but this is not a game. Well, this is a game. Yeah. For all intents and purposes, this is not a game object. It technically is, but I'm just simplifying it. It's not. It for people who know, this is a game object is I think a part of mono behavior. It's inheritancy. So, but anyways, I'm casting it as a puzzle piece, and then I'm calling create puzzle piece. And what we do here is create puzzle piece. Is that what that one is? Yeah. Yeah, and here we're scaling it and all that. And here I'm just setting up the selection graphic, and then I am hiding it because we don't want to see it until I have something selected. So here we set up the board and then we randomize the placement. So here, as you can see, I'm assigning the image to its correct location. If I go to assign image, I have a good offset. So this stores the puzzle piece that's required for you to win. So if I have, for example, if this one was 1, then this has to be 1 for it to be a good placement. So that's all what that is. And let's see here. And then I just set it to the scale and I go back into assign image offset, but it's going into this one here. And then, yeah, I'm setting up the offset. And yeah, I should explain. Technically, each piece has the entire texture or image. And what I'm doing is I'm kind of shrinking the window, so to speak, the viewing window, and we're only seeing a part of the image. So that's actually what we're getting at. If I was to... a good way for me to do this. Okay, yeah. So I'm just going to comment this out. Oh, I shouldn't be doing this on the fly. I'm going to get errors, I know it. Okay, going to build. Oh, yeah. Build again. And I'm going to run it. Yeah, so it's a different section. I don't know which one's which. And I think it's still off because of the scale. Yeah. So, but I'm not gonna continue on with that. There we go. Just built this again. And here I just check to make sure that the placement's good. So if good offset is equal to the offset that we currently have, that means it's showing the same piece. That means return true. That means that they are equal. Actually, my cats are running around upstairs. This can be optimized, I think, even further if I do it this way. See, look, we just optimized the code even more. So basically, if it's true, yeah, so I'm just returning the value. So, yeah, I don't need that anymore. Here we move up the puzzle piece and move back down. So let us go back here. Here we're randomizing placements. So I'm just grabbing 2 random places and just swapping the puzzle pieces. This is a do while loop, so it will always go into this at least once. And in the off chance that we randomly place the board in its correct order, it's like 1 in a billion or not that happens, go get a lottery ticket. We'll run this again. And we'll keep running it until we get something that's actually random. Here we get the puzzle piece selection. Then we set the selection. Here's where we check the board, so we see if all the parts are actually true or false. So here we're going through every single puzzle piece. We're checking its placement, and if it's false, that means that a puzzle piece is not in its correct spot. We don't have to keep checking anymore because we know the board's not valid, so we kick out. But if we go through all this and none of these were false, that means they're all true. So that's what that is. And here's just the win text. Here's just I made my own variable, just vector int2, just holds 2 ints. It's just so that I don't have to use these vectors because they hold floats, but I need integers for this one. Better than casting. What casting does is you can kind of think of it as turning a variable, that's a variable, an integer variable, into another variable. Like this is casting, that's casting, that's casting. Man, my cats are going crazy upstairs. Yeah, those are castings, and normally casting is slower than actually having the proper object. So that's why I did this here. And I would have had to cast it for each one of these, because this requires an integer. Anyways, so yeah, I talked about this one here, and so here's the selection one. So here we just set it up. Oh, and if you're wondering what this is here and why I'm just assigning it to its own transform, I don't know if this is still true, but in the older versions of Unity, at least from what I've been told, every time you call transform, like I could do this, that's still valid. That's still valid. But from what I've been told, at least in the older versions of Unity, is whenever you call this, it actually does a search for the transform of the object that you're in. Problem is, when you keep calling it, it has to search every single time you call it. So it slows it down. So what I'm doing right now is I'm holding a reference right here to the object that it finds. So I'm actually storing that value and I'm calling it. So this is basically in terms of speed versus size, I am increasing the size of my application a very, very tiny amount, but speed-wise, the application has increased greatly, and like a tiny amount. I don't know how much transform actually is, but it's a reference, so it's pointing to this. At least I'm assuming so in C#. I also know C++, and I know so many languages that they all kind of bundle up together. Okay, let's see. So scale X, scale Z, and here I'm just setting it up. Here, once we set the position of the selection graphic, we let it draw. We place it, and then when we want to hide it, we just call this. I mean, I could do another. I could just, instead of calling this, I could have it. I could program this in manually over. Where is it? Here. I could just do dot render dot, but let's keep things simple. It's the way I like to work. Oh yeah, and here, I don't know if I talked about this. So here is on mouse down. So this is the puzzle section, and when we click it, the puzzle section actually has let's the prefab here. It has a box collider. So here is if I hit the box collider, this is triggered. Then I make a previous selection and I see if it's not null. If it's not null, then I move it. That means basically if it's not null, that means it actually has an object. Then I move back the old piece. I swap the images. I hide the selection graphic because we have nothing selected anymore. I then set the selection to null because we have nothing selected. I then check the game board to see if we won. And if we win, I display the win message. And here is when you first select an object. Then we move up the piece, set up the selection graphic, and then we set the selection to this. This is basically the object that this was called in. So each one of these sections has its own on mouse down. Basically, they're kind of copies. Define image. Okay, yeah. So that's the little game I made yesterday. Like I said, nothing spectacular or anything like that. But I just wanted to show you guys. This is basically a little bonus video. Let's see if I can make another one. No, it goes there. But yeah, if you guys would like more of this, please let me know and I'll see what I can do. I'm not the best out there. Well, at least I don't think I'm the best out there. People say I'm good. I'm kind of meh. Come on. Okay, I gotta move that down. Alright, well, anyways. Do a let's play on just this puzzle game. So yeah, let me know what you think. Oh, and yeah, see here's all the copies. So each one of these has their own puzzle section script. So yeah, let me know what you think. If you'd like me to maybe do more of these, let me know. If they do, they will be few and far between, because it'll take me time to set something up. But yeah, that's a little gaming trick. So even though that this game looks 2D, technically it is 2D. It's a 2D game, but it's 3-dimensional. Yeah. Anyways, okay guys, well thanks for watching. Hope you enjoyed. And I'll see you guys next time. Bye!